Welcome to Olympian Water Testing, giving you the best in water analysis. Today we're looking at ammonia in distribution systems. First in the series, this is by the Minnesota Department of Health, and we're taking a look at what this looks like. So we can actually see a diagram taking a look at fossil fuel emissions, precipitation, lightning fixation, bacteria fixation, gastric atmosphere nitrogen store right here. You can see the fertilizers, runoff leaching, the ammonium, the nitrification, the nitrates, the plant consumption. As we can see, this is kind of circular, but the issue is with all this going on, it gets into runoff. There's leaching, and then it gets into the water supply. So many water systems in the state have already ammonium in their water or add ammonium during their treatment process. Excess free ammonium in water distribution systems promotes biological growth when nitrification, and your system experiences isolated areas of water quality degradation that affect the aesthetic quality of the water and generate customer complaints due to taste, odor, and particles in the water. So that is something to take a look at. We can also take a look at the nitrogen cycle here. Nitrogen is essential to all living systems, which makes it one of Earth's most important nutrient cycles. 80% of Earth's atmosphere is made up of nitrogen in its gaseous form. Nitrogen is removed from the atmosphere by lightning. During electrical storms, large amounts of nitrogen are oxidized and united with water carried to the earth in rain, producing nitrates. Nitrates are taken up by plants and converted to proteins, and then the nitrogen passes through the food chain from plants to animals. When they eventually die, the nitrogen compounds are broken down, producing ammonia. And some of the ammonia is taken up by plants, some dissolved in water or held in soil where bacteria converts it to nitrates through nitrification. And human activities cause increased nitrogen deposits in a variety of ways, burning fossil fuels in forests, which releases nitrogen into the atmosphere, fertilizing of crops and nitrogen-based fertilizers, which then take in the soil and water, ranching, during which livestock water releases ammonium into the soil and water, and leaching of sewage and septic tanks into streams, rivers, and groundwater. So we can see the chlorination, free chlorine, and chloramines disinfectant use in water systems do have their advantage. There's the head toric plate, the nitrification, and the Safe Drinking Water Act as well. But one thing we want to take a look at is the free ammonium and ammonia in your water system. So the term free ammonia is used when naturally occurring ammonia is present in water or when chloramines are used to disinfect water. During chlorination, chlorine and ammonia are added to water to form monochloramine. And the portion of ammonia has not been combined with chlorine is called free ammonia. It exists neither the NH4 or NH3 depending on the pH and temperature of the water. Typically the water pH of 7.0 to 7.8 and the temperature of 12 to 24 degrees Celsius. More than 96% of ammonia is in the ionized form of ammonium. As the pH and temperature increase, the amount of NH3 increases and the amount of NH4 decreases. So what about it in your water system? The only accurate way to determine if ammonia is to perform an ammonia analysis. You have to have it tested. And you have to test that if the ammonia is detected. Additional sampling on the distribution system for free ammonia should be explored. And if you've detected ammonia levels over 7 milligrams per liter in the groundwater, then that's something you need to take a look at because it's 0.2 to 0.2 milligrams per liter as the standard, and the ammonium is unregulated compound for the EPA, and it has not a required system for it. Now, there might be some indicators of ammonium and nitrification based on the disinfectant. So if you observed increased difference between free and total chlorine, that may be ammonium. So if you see something from 1.2 to 1.5 milligrams per liter free chlorine in the range of 0.1 to 0.3 milligrams per liter, differences between the two are significant. So beware of free chlorine as well, and also take a look at things like low total chlorine, pH drop, and an increase in HPC bacteria. So that's an idea of ammonium, some of the science behind it, and what goes on. As we can see, this is not good for the environment, and also the cycles that goes through, and free ammonia, what's happening here could pose some issues. Now, ammonia is not necessarily harmful in low amounts, but high amounts it is. So it's always a good idea to periodically test your water.